Hello everyone. So in the last couple of videos we learned about the left endpoint rule and the right endpoint rule. But every time we use one of these methods, we saw that they actually either overestimate or underestimate the actual area, right? So how do we know which method will give you an overestimation or an underestimation? Well, the answer to that question is it really depends on the behavior of the function and also the method that you use, okay? But if you know the behavior of the function and if you know the method that you're going to use, you can predict that, well, if you use this method or that method, I will get either an overestimate or an underestimation. We can predict that, okay? So let's see how we can make that prediction. First of all, it depends on the behavior of the function. So let's first look at increasing functions. So if you have an increasing function, so increasing function means when you take larger and larger x values, when you keep on taking larger and larger x values, your y values increase, okay? So your function is strictly increasing. So if you have a function like that, and let's say you want to approximate the area in this region, how about if we use left endpoint rule? So let's use left endpoint rule. Let's see what happens. So let's have some subintervals. Now left endpoint rule means you connect the leftmost point of each subinterval to the graph and create rectangles, right? Now see what happens. If I use the leftmost point, I actually get what? Overestimation or underestimation? You can see I get an underestimation, right? All right, underestimation for left endpoint rule. So let me write it as left L dot R. So L dot R means left endpoint method. As you can see, for an increasing function, if I use left endpoint method, I get an underestimation, because you can see the area that's coming from the rectangles are smaller than the actual area. As you can see, we have some leftover space, right, that these rectangles didn't cover. Alright, now actually it makes sense. I mean, think about this. Think about a one particular subinterval. So in this subinterval, we use the leftmost point to create this rectangle, right? Now the height becomes this left endpoint method. A left endpoint, the leftmost point. Now since this is an increasing function, and in this subinterval, since the function is increasing, this leftmost point is the smallest point in that subinterval. So it's going to create the smallest height because the function is increasing, right? Then if you use the leftmost point, of course you're gonna get an underestimation. Of course your rectangle is going to be under the curve. Alright, so let's say that we have an increasing function again. Now shall we use the rightmost point? So let's create this subinterval. We are going to use the rightmost point, so that means we are using the right endpoint rule. Probably you might have guessed what's going on. My rectangles are not beautiful, but if I create the rectangles, yes, you guessed correct, we are gonna get an overestimation, right? Overestimation. Now this is from the right endpoint rule, so let's write r dot l. So we get overestimation. So for an increasing function, if you use the right endpoint method, we get an overestimation, because the rectangle, the area that this rectangle cover is actually larger than it exceeds the actual area, right? It goes above the curve. Now why this happens? Think about this. Again, take a subinterval, particular subinterval. So in this subinterval, the function is decreasing. So when we use the rightmost point, okay, if you use the rightmost point, the rightmost point will create the largest height, right, out of the two endpoints. So when you use this largest height, the rectangle actually exceed or go over the actual curve. All right, so that's why we have an overestimation with right endpoint rule if you have an increasing function. All right, so let's flip that. How about if we have a strictly decreasing function? Now I guess you can probably predict it, right? Let's use left endpoint rule. Now let's create the subintervals. So let's connect the leftmost point with the graph, okay, And if we create the rectangles, as you guessed, we get an overestimation now, exact opposite of what happened in increasing functions. So in increasing functions, if you use left endpoint rule, you get an underestimation. Now in a decreasing function, if you use the left endpoint rule, you get an overestimation. Okay, now why is that? Again, take a particular subinterval, think about it slowly. Okay, so if you take this subinterval, the function is decreasing, right? So the leftmost point in a decreasing function will give you the largest height, right? Out of these two heights, this is the largest, right? So that largest height will create a rectangle that go over the curve, right? Above the curve. So that's why we will have an overestimation if you use the left endpoint rule with a decreasing function. Alright, now I guess you can easily foresee what's going on. So we have a decreasing function and we are going to use right endpoint rule. Now you know you're going to get an underestimation, right? So let's confirm that. So we connect the rightmost point to the graph and we create the rectangles, right? These rectangles, and we see we get an underestimation, right? The rectangles are below the curve. Okay, we have some leftover space that these rectangles didn't cover. All right, so that means for right endpoint rule, we get an underestimation for decreasing functions. Okay, but for increasing functions, if you use the right endpoint rule, you get the overestimation. You get a overestimation. All right, now this is something that you should know, but not something that you should memorize. Okay, I mean you can figure it out if even without memorizing. Just draw an increasing function and just draw these rectangles depending on the method you have. Then you can easily predict, you can easily see for yourself whether it's an underestimation or overestimation. But in increasing and decreasing functions, exact opposite happens. Okay, so for an increasing function, left endpoint rule under, for decreasing function, left endpoint rule over. For right endpoint rule increasing function, it's over. For right endpoint rule decreasing function, it's underestimation. Okay, all right, so that's it what I have for this video. I'll see you in the next one. Thank you.